All right, welcome to day 4 of Algebra 1. Today's goal is this the same as the last 2 days. We are still going to be looking at linear functions and their key features, specifically x-intercepts, y-intercepts, zeros, and slope. Today's specific focus, though, is going to be on types of equations that are not in slope-intercept form. So when you come down here, you'll see the success criteria is a little bit different today. It's that we can substitute 0 in for y to calculate the x value. We will substitute 0 in for x to calculate the y value. We can then write the x and y intercepts as ordered pairs, and we can graph it using those ordered pairs. Okay, so that's going to be our success criteria as we go today. So let's look at the first stage here. The first stage, we're going to just review one-step equations because this is what we're going to be doing a lot of today. When you solve an algebra, so algebra, what that means, algebra is that you're including letters of the alphabet into the math. Hey, stay over here with me, Edgar, please. It means you're including alphabet in the math. So you see how I have the letter X here? We're going to have to use algebra to solve this. The key to algebra is to know your opposite operation, or true name, inverse operation. So for example, what's the opposite of adding? Subtraction. What's the opposite of subtraction? Addition, adding. What's the opposite of multiplying? Division, dividing. And what's the opposite of division? Multiplication. Okay, so when you want to solve for a variable, the key is to know your opposite. So if I wanted to solve for this x, so we're going to be solving for a variable all day today. If I want to solve for this x, I have to know what's the opposite of any of the math happening next to it. So what's the 3 doing to the x? Is it adding, subtracting, multiplying, or dividing? This 3 is adding. So to solve this, you have to know what's the opposite of adding 3. Hey, everybody speak up. What's the opposite of adding 3? Subtracting 3. So on your notes, go ahead and let's subtract 3 from both sides. Whatever you do on one side of the equation, you have to do it on the other to keep it equal. We want to keep this whole equation balanced and equal. So when I take away 3, the plus 3 and the minus 3, since they are opposites, we simplify those, we cancel them out. And you're left with x equals, now here's a question for you. What is 10 minus 3? 7. 10 minus 3 is 7, and that would be our solution. Now this is called a one-step equation. Let's try another one. Let's come over here. This time it says x minus 5 equals 2. Now, question for you. What are we solving for? What is the unknown algebra variable? Gustavo, what's the unknown algebra variable in number 2? X. We're solving for x. So we want to get x by itself. Since I need to get x by itself, I need to get, that's called isolating the variable. I need to get rid of anything next to it. So here I have a minus 5. What's the opposite of minus 5? Addition of 5. Let's add 5 to both sides. When I do that, the minus 5 and the plus 5 simplify. They cancel out. And so I'm left with x equals 2 plus 5. What is 2 plus 5?
7.
7. Perfect. That would be my answer there. Let's jump to number 3. Number 3 says 9x equals 18. Same question, this time to Julia. What is our algebraic variable that we have to solve for here? X. We got to get x by itself. Here's the question. What's the 9 doing to the x when it's right next to it like that? Is it adding, subtracting, multiplying, or dividing? It's multiplying. Perfect. What's the opposite operation of multiplication? Division. We need to divide both sides by 9. So once again, multiplying, division, they are opposites. You can simplify those. You can cancel them out. And you're left with x equals, does anybody know 18 divided by 9, what that is? Deja.
2.
It's 2. 2 is your answer here. All right, last one. Number 4. We have x over 7 equals 10. Another way of saying this is x divided by 7 equals 10. Okay, what are we solving for? What are we trying to get by itself, Carla? X. What's the 7 doing to the x? Is it adding? Is it subtracting? Is it multiplying? Or is it dividing right now? What's it doing? Dividing. What's the opposite of division? Multiplication. We need to we need to multiply both sides of this equation by 7. I'm going to use a dot for multiplication. You can do an X if you want, but I'm going to use a dot. So the 7s that's multiplying and dividing cancel each other out. They simplify. They're opposites. And so we're left with X equals, mental math, 10 times 7. 70. Good, Valentine. And that would be our answer. Okay, I'm going to let you practice just showing your steps. Here, if we need a calculator, we can get a calculator out in a little bit. Don't worry about simplifying. What I want you to do, flip on over to 5 through, or these number 1 through 8 here. And I just want you to show me the step. If you don't know what the math actually equals, that's okay. We'll bust out calculators at the end. Whoever gets ahead can simplify them all for us. Just show me the step that would simplify all of those. Okay, so you don't actually have to simplify and do the math. Just show me the work of what the opposite is every time on this slide. I'll give you a few moments to work. All right, ready, go. Okay, I'm going to pick up with you. So on the first one, 14k equals 126. We're needing to solve for the algebraic letter, the k. What's the 14 doing to the k right now? Adding, subtracting, multiplying, or dividing. What's it doing when it's next to it like that? Multiply. What's the opposite of multiplication? Division. So we would divide by 14. And that's how you get k by itself. Now, some of you have already gotten through these, and so you might have your calculator open. You may have gone to Google Classroom, clicked on Algebra 1, classwork, and then at the very top, you'll see the Desmos Star version. Click that. This is what you'll be given when on any test day that you take in my class. I want you to make sure you get your best grade possible on any tests. So that's the one I want you to open up. 126 divided by 14. What did you get when you typed that into your calculator? I'm waiting on mine to load. 126 divided by 14. Here we go. 126 divided by 14. What'd you get? You get 9 like me? That's the answer. The answer is 9, okay? So our first answer is 9 here. Okay, how about number 2? On number 2, we have 14y equals negative 56. What would you do on this one? We're solving for which letter? How about that? What letter are we solving for on number 2?
Y.
Y. What's the 14 doing to the y? Adding, subtracting, multiplying, or dividing? Multiplying. So if it's multiplying, what's the opposite of multiplication?
Division.
Division. So we would divide both sides by 14. Now let's go type this in the calculator. It's negative 56 divided by 14. So negative 56 divided by 14. Negative 4? Great. Negative 4. That is our solution there. Okay, how about the next one? 8x equals 104. Edgar, what's the algebraic letter that we're solving for? X. We got to get x by itself. X is next to 8. What's the 8 doing to the x? Is it adding, subtracting, multiplying, or dividing? It's multiplying, so we have to do the opposite. What's the opposite of multiplication?
Division.
Division. We got to divide both sides by 8. We need to divide both sides by 8. Now you might be noticing we're doing a lot of dividing. That's because that's what we're going to do today. I want to make sure we know how to do it. So take 104 and divide that by 8. 104 and divide that by 8. 13. Great. So x is equal to 13. Okay. This one's a little trickier. 6 equals negative b. What is our algebraic variable this time? That means the letter. B. We need to get b by itself. Is b by itself right now? No, it has a negative. If you ever see a negative and there's no number, that means it's negative 1. So if you can, sneak in a little 1 right there, a negative 1. Now, what's that negative 1 doing to the b? Is that negative 1, Valentine, Is this -1 adding, subtracting, multiplying, or dividing the b if it's right next to it like that? No, if it was subtracting, it'd be -1 over here. So if it's attached to it, is it adding, subtracting, multiplying, or dividing right now? No, it's not dividing. If it was dividing, it would be down here. What's it doing right now? It is multiplying. Now, what's the opposite of multiplication?
Division.
Division. So now let's write divided by -1. And so we're going to take 6 and divide that by -1. That's our step now. Take 6 and divide that by -1. What is 6 divided by -1? -6. You can leave the b second, or you can rewrite it with b first. That's what I'll do. I'm going to say b is equal to -6. Okay, so I've kind of guided you through it. This time I want you to kind of guide me through it. Valerie, would you like to go first? She says no. Walk me through number 5. What do you notice about number 5? We got to get rid of the -7. You're correct. How do I get rid of this -7? What's it doing? It's multiplying. What's the opposite of multiplication?
Division.
Division. Let's divide to both sides by -7 then. And so y would equal 21 divided by -7. 21. I'm going to do this so I can see both my calculator and that at the same time. Well, not enough. 21 divided by -7. Are you getting -3 like me? Yes. I need to refresh that so I can see more. So it'll be -3. Okay, next one. Deja, what would you do for the next one? It is multiplying, so what would you do if it's multiplying? Okay, so if this is multiplying, we divide by what number? 10, perfect. So we're typing in -40 and dividing that by 10. -40 and dividing that by
-10.
10.
Wait.
-4? -4, yeah, good correction, good correction. Heard you the first time, and I heard you correct yourself, good. -4. Okay, last two. Gustavo, what would you do here? What are we solving for? We're solving for 5? What's the letter? What's the letter that you see? A. That's what we're solving for. So we have to get A by itself. What's with the A right now? 18. What's the 18 doing to the A? Is it adding, subtracting, multiplying, or dividing? No, if it was adding, it would have a plus. When they're written in front, what's it doing if it's written in front? It's multiplying. Let's sneak in a little dot there. That's multiplying. So what's the opposite of multiplying by 18?
Division.
Dividing by 18. Okay, we're going to get a weird answer in the calculator this time. Nevertheless, we're still going to do it. Let's -5 divided by 18. Oh, it goes on and on and on and on. So let's write it as, should we just leave it like that as a fraction? Or do y'all want to round it? Y'all want to round it? How many decimals should we do? Let's do 2 decimals. -2 point. If I was going to round this to this value right here, do I leave it as a 7 or does it round up to become an 8? Rounds up to become an 8. We're going to say it's -2.8. Now, what I do anytime I round, I do the approximately symbol. That means like that. I do that anytime I round. Whenever you see me do a squirrely little equal sign like that, that means approximately, that means I have rounded my value. But that wasn't the exact value, I rounded it. That's what that means. All right, last one, number 8. What should we do for number 8? What are we solving for again? Jose, what are we solving for this time? What's the letter you're solving for? X. What do you see is happening with the X? What number do you see with the X? Negative 11. What's the negative 11 doing to the X? Is it adding to the X, subtracting to the X, multiplying the X, or dividing the X? If it was adding, it would have a plus. Doesn't have a plus. When a number is written right next to a letter, it means it's multiplying. It's the only one that doesn't have to show you this symbol. It's multiplying. What's the opposite of multiplication? Division. Let's divide both sides by negative 11, and we will have completed this slide here. Negative 143. Negative 143 divided by 11. Are you getting, whoops, no, it was divided by negative 11, wasn't it? Is that right? Negative 143 divided by negative 11. Are you getting positive 13? That's what I'm getting, positive 13. That would be your answer. Positive 13. Okay, so why did I practice so much of that? Today we're going to look at standard form of lines, which is going to look a little bit different. So the equations are going to look a little different than we've seen. So starting on this next one, what we're going to do here is we're going to look at how we're going to graph lines when the equation is given in this form like that. So it says here, let's graph the line represented by the equation 2x plus 3y equals 6. So here's our steps. We're first going to substitute a 0 in for x and simplify to find the y. Now there's a shortcut for this, but I'm going to write out all the steps first. Edgar, stay with me now. Okay, here's what we do first. We're going to substitute. You know what substitute means? What does it mean in athletics if you do a substitution? Someone goes in and someone else comes out. That's what we're going to do here. The 0 is going to go in and the x is going to come out. Now, whenever you substitute, we substitute. Typically, we like to write it with a parentheses, but it's going to replace. So here's what I'm going to do. I'm going to take my equation. You see, here's my equation right there. We're going to put in a 0 for x. So x comes out and 0 goes in. I shouldn't have asked you this. What's the 2 doing to the x right now? Is it adding, subtracting, multiplying, or dividing? Multiplying. So I'm going to take my equation, that equation right there, and we're going to substitute. It's going to become 2 times, instead of 2 times x, it's going to become 2 times what number instead? X is coming out, and what's going in? 0. So I have 2 times 0 plus 3y equals 6. Now, what we're going to end up finding is the y-intercept. Now, you might remember the y-intercept is when x is 0. That's why I just put 0 in for x, is because of my x value is 0. What we're trying to find is what's my y value. That's what we're trying to find. So, what is 2 times 0? 2 times 0 is not 2. 2 times 0 is 0. And what's 0 plus 3y? When you add 0, what do you always get? The same number you already had. So here's what's going to happen every time. Whenever we substitute in this equation, the value we substitute, that 0, is going to cancel out. It's just going to disappear. So we're left with 3y equals 6, just like that thing we just practiced. So now I'm going to ask a different question. What's the 3 doing to the y? Is it adding, subtracting, multiplying, or dividing? What's that 3 doing to the y? It's multiplying. What's the opposite of multiplying by a positive 3? Division. Let's divide by a positive 3. The plus just means it's positive. It's not negative, it's positive. Those simplify out, and we're left with y equals, do y'all need to type this in the calculator, or do you know it? 6 divided by 3. 2. Y equals 2. That's our y-intercept. So that right here represents our y-intercept. Notice this is the x value. I want to make sure everybody's clear. The x value is 0 because that's what we substituted in. The y value is 2. So we go to the graph. When x is 0, this is 0 right there. X-axis, y-axis. Put a dot when so x is 0, y is 2. Put a dot right there. There's our point. That's the y-intercept, okay? That point right there is 0, 2. Just want to make sure everybody's following along, no one's confused, okay? Now, what you do is you start back over, but this time we're going to put a 0 in for y. It says substitute 0 in for y. So I'm going to take the same equation, but this time I'm going to substitute 0 in for y. So I leave the x alone this time. Nothing changes with my x value. Oh no, my computer's freezing. Okay, it's back. Okay, so we leave the x alone. It's 2x plus 3. Now, what's this 3 doing to the y right now? Multiplying. So instead of saying 3y, we're going to do 3 times. And what are we substituting in for y? 0 equals 6. So what we're doing is we're finding the x-intercept. What we now know is that the y value is 0. That's why we plugged in a y value of 0. We're now looking for the x-intercept. What is 3 times 0? 3 times 0 is 0. Now, once again, it's adding. Whenever you add by 0, does it change the number? No. So this part will always cancel out. That's what I mean. It's a shortcut. You don't actually even have to write that part down. When you substitute a 0 in, it's just going to cancel out. And so you're left with whatever else is there. So in this case, we have 2x equals 6. Okay, we got to get this x by itself. What's the opposite of this, or what's the 2 doing to the x right now? Multiplying. What's the opposite of multiplication?
Division.
Division. Let's divide both sides by 2. So x would equal, what's 6 divided by 2? 3. This will be our x-intercept. Once again, the x value is 3. The y value is 0. So this time, go to your x-axis, go to 3, and draw the dot. When y is 0, x is 3. It's that point right there. Everybody got that down? Now take your ID badge and draw a line connecting those 2 dots, and we'll be done. Take your ID badge and draw a line across the graph that connects those 2 points. It looks like I just missed a little bit on mine. So something like this. That's what your line should look like. Use your ID badge and connect those. All right, so that's the process that we're going through today. Now let's practice that again. Let's see it here. Example 1. Which graph represents this? So this time we don't have to take the time to graph, but we still need to solve the same way. This is written in standard form. This means that x and y are together. If they're written in this form, we're going to do the same 3 steps. Do you remember what the first step was? What did we just do a second ago as our first step? Look back on this slide. What do we do first?
Substitute
0 and for x. So that's what I'm going to do here first. I'm going to substitute 0 for x. That's what we're doing first. So I'm going to take this equation. Right now, there's the x. What's the negative 3 doing to the x? Multiplying. So what I'm going to write down first is negative 3 times, and instead of x, what are we going to put instead? 0 plus 5y equals negative 15. Everybody good there? Now I told you there's a shortcut. Whenever you substitute a 0, what happens when you multiply by 0? What's negative 3 times 0? 0. And then you're going, in this equation, you'll always either be adding or subtracting 0. When I add the 0, what happens when you add by 0? Does it change the number? No. So this part will always cancel out. You don't even have to deal with it. So when I substitute 0 in for x, the x portion in the equation just cancels out. That portion cancels out. And so we're left with positive 5y equals negative 15. And now it's just like that page where it said, let's practice with the 8 problems. What is that 5? What's the 5, this positive 5 here, doing to the y? Is it adding, subtracting, multiplying, or dividing when it's written right next to it? Gustavo, make sure you're not distracted by a computer. You can pull it shut. Go for it. Make sure you're looking at me. What is that positive 5 doing to the y? It is multiplying. What's the opposite of multiplication? Division. Let's divide by 5. A positive 5, not a negative 5. We're dividing by a positive 5. And this will give us our y value, our y-intercept. Negative 3. Good. You did not need the calculator for that? Good job. This means the x-intercept. Why is it the x-intercept? Because we put 0 for x. The x value is 0. The y value is negative 3. This is our y-intercept. That's what that will be, the y-intercept. I hope you're okay if I just say y-int. That's the y-intercept. I'll go ahead and write the whole thing. The y-intercept is 0, negative 3. Okay, so let's look at our graphs. Let's see if A is potentially correct. Here's the y-axis. Where does this line cross the y-axis? Negative 3. Okay, that's potentially an answer. See, that one's good. Where does C cross the y-axis? Oh, you see how that one crosses at 5? Is that a good answer or a bad answer? Bad answer. That's not going to be correct. That crossed way up at 5. So that's not a potential answer. Okay, let's now go look at B. Where does B cross?
5.
It crosses the y-axis at negative 3. Is that a potential answer or not a potential answer? Yes. So it could be A, it could be B. All right, what about D? Where does D cross the y-axis? It crosses up at 5. Is this a potential answer or not a potential answer? Not. This is wrong. So D is out. Everybody following how I'm doing this? Okay, so now we got to go do step 2. So step 2, if step 1 was to substitute 0 in for x, step 2 is you substitute 0 in for y. So we're going to take our equation. The thing you have to observe is what is this positive 5 doing to the y? Adding, subtracting, multiplying, or dividing? Julia, stay with me, please. What's this positive 5 doing to the y? Multiplying. So when I substitute 0 here, I need to make it a multiplying by 0. So it looks like this. Negative 3x plus 5 times 0 equals negative 15. Now I told you a few times, when you substitute 0, what can you do with that part of the equation? Okay, you haven't caught yet. You can always cancel it out. Let me show you why. What is 5 times 0? 0. When we add 0 to the negative 3x, what's going to happen to the negative 3x? When you add a 0 to it, what's going to happen? Nothing. So wherever you substitute the 0, that part will always cancel out. We already said the negative 3 was multiplying. So now I'm going to pick up right here. What's the opposite of multiplying by negative 3 to the x? The opposite of multiplication is more multiplication. Is the opposite of multiplication addition? Now, y'all keep telling me. The opposite is division. Y'all are correct every single time you said that. This would give us our x value. A negative divided by a negative is a positive number. Do you know what negative 15 divided by negative 3 will simplify to become? It will be a positive number. Positive 5 is correct. So our x-intercept this time it's an x-intercept, has an x value of 5 and a y value of 0. If you're wondering, wait, where did I get the y value of 0? That's what we substituted in. We said when y is 0, we got x would equal 5. Okay, so let's go see which one's correct between A and B. On A, what's the x-intercept? Oh, it's -5, isn't it? Is that good or bad? That's bad. This one has a 5, so the answer is B. A is wrong because of that x-intercept. Now we've done these, we could do a practice problem here. Let's go to DOL number 1. Let me get where you can see the whole picture. I want you to try to solve this one. Which one works out right? Okay, if you finish the first one, now work on the second DOL. Here's another equation. Try this one. All right, example 2 is now where we're going to pick up. It says here, Allison wants to graph a line, and she knows the equation right here. What strategy would you suggest to her? Is this the slope-intercept form, y equals mx plus b, or is this the substitution form? Which form is this equation in? Can I get your eyes on it? If you were going to graph this line, which form is this in? Is this the y equals mx plus b slope-intercept form that we were working with before, where you graph the y-intercept then the slope? Or is this the one where we need to substitute? Which form is this one in? So you see how the x and the y are together this time? When the x and y are together, that's when we do the substitution technique. So the strategy I would suggest is we do substitution. Since the x and y are together in the equation, I would do substitution. Now, since we're substituting, what value do we always substitute in? What's the easiest value to substitute in? Is it a 1? Is it a 5? Is it a 10? Is it 100? What's the easiest number to substitute with?
0.
0. We're going to substitute with 0. Do y'all want to substitute 0 in for x or for y? X. Okay, what I'm going to do here is in parentheses, I'm going to put a 0 in the x spot. So we're substituting x and 0 in for x. What's the 4 doing to the x right now? Multiplying. Do I actually need to write that down? Do I need to write down the 4 times x, 0? Do you have to do that? No, you don't. You do have to write the rest of the equation, but you don't have to write the 4 times 0, because what happens when you take 4 and you multiply it times 0? It becomes 0, and then when you add or subtract by 0, it always cancels out. So you can just take away the 4x when you rewrite it. Okay, this is almost solved, but not quite. I have a negative y. That y is not by itself. It has a negative, but it doesn't show a number. What's the hidden number that's attached to the y if it doesn't show one? It's a 1. This is -1 there. What's the -1 doing to the y? Is this -1 adding to y? Is the -1 subtracting the y? Is the -1 multiplying the y or dividing? It's multiplying. What's the opposite of multiplication? Division. We need to divide both sides of this equation by -1. When we do this, we find out that y equals, do y'all know what a negative divided by a negative is?
-8.
Okay, if it's two negatives, the negatives actually cancel and it becomes +8. So we have our y-intercept. Is this point up 8, right 8, down 8, or left 8? Where would I graph that? if it's the y-intercept. Up. So go from the origin straight up and plot that point. That is 0, 8 right there. Now, what's the second? How do I get the second point? What do I do different to get the second point? We substitute a y value of 0. So this time I'm putting in a y of 0. Do I need to write the 0 in for y? Do I need to write down that part of the equation with a 0? No. Why not? It always cancels out. So you don't have to write it. So we need to solve this here. Gustavo, what would you do? What's the 4 doing to the x? Adding, subtracting, multiplying, or dividing? It's multiplying. What's the opposite of multiplication? No, opposite of multiplication is not adding. Dividing. Let's divide both sides by 4. So I get x equals, what's negative 8 divided by 4? Negative 2. That's the x value. So is that up, down, left, or right 2 units? If it's the x, negative 2. So I go up, down, left, or to the right 2 units? Left. Go left 2 units, draw a dot. That's the point, negative 2, comma 0. Last step. How do we draw the line? I would recommend you bust out your ID badge to help you draw a straight line. And I want you to connect those dots going across. So connect those dots just like that, and you'll have your line. There you go. That's how, those were our steps there. Okay, so earlier, those were our 2 steps that we did, and then we used our ID badge to draw it. That was our 3rd step. This one, we just had the first question here, what strategy to use, and I use substitution. Okay? Let's look at example 3. Example 3 here. It says, what is the x-intercept of the graph that is represented by this? Okay, help me out. When you write an x-intercept, what form does an x-intercept look like? Like, I know it has a 0 somewhere. If it's an x-intercept, which value is a 0? The y, good. So what does that mean I could do as a shortcut on my equation if I know y is 0? I would substitute it in. Now, do I actually have to write it out like this? No, what can you do whenever you're substituting in a 0? Cross it out. And so what would my x-intercept here? I don't have to do any extra work. What is my x value going to equal? 4. My x would be 4. Or how about the next one? It says, what's the y-intercept? Anytime you have a y-intercept, and if it's an intercept, one of the values is a 0. If it's a y-intercept, which value is 0? X. So how could I solve for this? If I know x is 0, what can I do in my equation? Yeah, you could cross out because you'd substitute in a 0 right there. It would be negative 4 times 0 plus y equals 8. Now, you don't have to write negative 4 times 0 because what is that always going to simplify to become? 0. So that cancels out. And what do we have left over for y? 8. The y-intercept would be 8. Okay, with this, I believe we've come to our last couple DOLs. I want you to look at this equation and then after, look back at this one. So you can just pause the video if you need to on DOL number 3. But then after you get this, try DOL number 4.